Good morning friends. In the previous lecture we were solving exercise 8.1. Now in today's lecture friends we are going to start with the next topic, that is trigonometric ratios for some specific angles. How specific angles? In this topic we are going to start with some of the angles related to the right angle triangle. Suppose if we have a right angle triangle, that means this one of the angle here would be 90 degree, as we all know, but we don't know what these two angles will be. Suppose if I name this as B, this as A and this as C, so we know that angle B is equals to 90 degree. And one more thing, we know for a triangle that in triangle ABC, angle A plus angle B plus angle C is equals to 180 degree, right? Because some angle property, the sum of all the angles of a triangle is 180 degree. If we replace angle B equals to 90 here, that gives me angle A plus angle C is equals to 180 minus 90, which is again equals to 90. So the sum of these two angles, that is equals to 90, and alone angle B is also equals to 90. So in this topic friends, we are going to discuss about some of the angles which makes the sum of angle of these two, the remaining angles, is equals to 90. So first of all we shall discuss that if angle A is equals to 45, then what will be angle C? Because A plus C is 90. If A is equals to 45, then angle C must be 45. So angle C is also equals to 45. So we got one of the pairs, that if two of the angles is 90. Then the second pair is if angle A is equals to 30. So if I put 30 here in place of angle A, then 30 will be taken on the other side. We get angle C is equals to 60. And if I take angle A is equals to 60, then we get angle C equals to 30. In short, friends, in short, the sum of the angles of angle A and angle C must be equals to 90. So you can check 45 plus 45 is 90. 30 plus 60 is 90. 60 plus 30 is also 90. And the third pair is if I take angle A equal to 0, then angle C must be 90. Or if I take angle A equals to 90, then angle C must be 0. So this is the third pair that we are going to discuss here. Right? So these are the specific angles that we are going to discuss here. The specific angles are combined 0, 30, 45, 60 and 90. These five angles are required to us to study in this chapter. Only these five angles. And friends, one more thing, that for the further studies you will be required to find out the specific ratios, not specific, trigonometric ratios for specific angles for these five values only. That means you will be required to find out the ratios of sine, cos, tan, cot, sec and cosec for the angles 0, 30, 45, 60 and 90. So we will study only these much angles, and then that's it for the topic of this trigonometric ratios for the specific angles. So that was the brief introductory part of this topic. Now let us check it for the ratio for angle 45. The first topic, trigonometric ratios for some specific angles, and under that we have our first angle as 45. Right? So before starting with this angle, I have taken here a triangle here. In triangle ABC, angle B is equals to 90 degree. As we all know that angle B is equals to 90 degree, and we will take AB equals to BC and AB equals to BC, that is let that means we are assuming that AB is equals to BC. That means these two sides are equal. Now, as we have studied in 6th chapter, that in triangle ABC, if AB equals to BC, then angle A is equals to angle C. Why? The reason being not sides, angles, that is the converse that I have written, angles opposite to equal sides are equal. Angles opposite to equal sides are equal. That is the theorem that is being covered in chapter number 6. So we got angle A is equals to angle C. Let me name this as star. Right? And also angle A plus angle B plus angle C is equals to 180 degree, right? Is equals to 180 degree. Sorry, let me write down again. Equal or equal. This is equals to 180, and the reason being that is for angle sum property. Angle sum property, that means sum of all the angles of a triangle is equals to 180 degree. So angle A plus angle B plus angle C is equals to 180 degree. Right, here we are having this triangle and this triangle here. This can be applied, the angle sum property can be applied to this triangle. Right, now we are having angle B equals to 90 as we already know, and by star we know that angle A is equals to angle C. Therefore angle A plus 90 plus angle A is equals to 180 degree by star. Star, that means in place of angle C, I have replaced angle A, and angle B is equals to 90 is already being replaced. Therefore angle A plus angle A, that is 2 angle A is equals to 180 minus 90. This 90 will go on the other side. Therefore 2 angle A is equals to 90 degree, and this implies angle A is equals to 45 degree. Right? Angle A is equals to 45. Angle A equals to 45. How? This 2 will go in the denominator of 90. That will be cross multiplied. So 90 divided by 2, and that is angle A equals to 45. Therefore again by star. Therefore angle A is equals to angle C is equals to 45 degree. Yes or no? So we got our required angle. Now this angle is 45 and this angle is also 45. Is it clear? Yes or no? Okay. We have let this as AB equals to BC. Therefore let AB equals to BC equals to K, say. So we will let this now equals to K both, because AB is equals to K, so BC will also be K by this, right? And AB square plus BC square is equals to AC square, because this is a right angle triangle. So sum of the squares of the side making right angle is equals to square of the hypotenuse. Therefore K square plus K square is equals to AC square, that is 2K square is equals to AC square, and hence AC is equals to root 2K. So we got our hypotenuse here as root 2K. This is K, this is K, and the hypotenuse is root 2K. Friends, why did we do this? The question. I didn't say that what to do here now, right? Why did we do this is the question. We have already studied this in the previous exercise. Why did we do this? AC. What we are studying right now is the trigonometric ratios. So ratios means we have studied in the first topic sin A, cos A, tan A, cot A, sec A and cosec A. And for applying these ratios, we will require the sides. So in the first place, we have taken this AB equals to BC equals to K, right? And in the second place, we have let that these both sides are equals to K. Yes or no? Right? See, if you will look in the textbook, this derivation is being not carried out, that why this angle A is 45. We are carrying this out right now because we have yet not studied about chapter 6, the fundamentals of chapter 6. So we will study in the next topic, in the next chapter after completing this chapter number 8. So for that I have simply carried out the derivation here, and then we have started with our thing that let AB equals to BC equals to K. So our actual derivation starts from this part, let AB equals to BC equals to K. And in the right angle triangle, AB square plus BC square equals to AC square. So here, friends, AC equals to root 2K is the hypotenuse that we have got. Now you can clearly see in the triangle that we have got all the three sides. The first one K, second one is also K, and third one, that is hypotenuse, is also equals to root 2K. So now can we find out the ratios? Yes or no? Yes, we can easily find out the ratios. So let us find out the ratios for each and everything. First of all, we will find out the ratios for sin A. But here, what is A? Angle A is equals to 45. So now, friends, in the previous topic we were writing down sin A. But now we will not write down sin A because we are now having the value of A, that A is equals to 45. So we shall write down that sin 45 is equals to, the ratio remains same, the only thing that is changed here is the value of A. So now we will write down sin 45 is equals to, so what is the ratio for sin 45? Opposite side divided by the hypotenuse. If we take this as our reference angle, then opposite side is BC divided by hypotenuse is AC. BC upon AC. What is BC? K. AC, that is root 2K. K and K is cancelled, and hence we get sin 45 as 1 upon root 2. Is this thing clear or not? Right? Again, let me confirm, sine of A, that is sine of 45, that is opposite side divided by hypotenuse. Opposite side is K, hypotenuse is root 2K, and hence we can say that BC upon AC, that is K upon root 2K, K and K is cancelled, and hence we get the ratio 1 upon root 2. Similarly, we can find out the ratio for cos 45. What is the ratio for cos 45? Again, we shall take this as the reference angle, friends, for now. Okay. So that is adjacent side upon hypotenuse, which is equals to AB upon AC. AB is again K. AC is again root 2K. K and K are cancelled. And hence we get cos 45 as 1 upon root 2. Right? So you can clearly see that, friends, sin 45 BC upon AC, that is 1 upon root 2. Cos 45 AB upon AC, that is also 1 upon root 2. So is this thing clear? For both the ratios, sin 45 and cos 45, we get the same values, that is 1 upon root 2 and 1 upon root 2. Friends, if you don't know, then let me confirm that the easiest ratios are for angle 45. The easiest ones are for angle 45. Okay, we will see it how. Now let us find out the third one. Tan 45. Tan 45, that means tan A, that is opposite side divided by the adjacent side. So opposite side, that is BC upon AB, and hence BC is K upon AB is also K, that is 1 upon 1, which is equals to 1. right? So the ratio for tan 45, that is equals to 1 upon 1, which is equals to 1. We got the third ratio here, that is tan 45. So we got three ratios till now: sin 45 1 upon root 2, cos 45 1 upon root 2, tan 45 is 1. We will find out the fourth ratio, that is cot 45. What is the ratio for cot A, friends? The ratio for cot A, that is side adjacent to angle A divided by side opposite to angle A. So if I am writing cot 45, that means adjacent side, which is equals to AB upon BC. AB is K, BC is also K, which is 1 upon 1, and hence the ratio again is equals to 1. Are you noticing anything? See this both, sin and cos 1 upon root 2 and 1 upon root 2, tan and cot 1 and 1. We are getting the similar patterns. Pattern similar, that means the value of sin 45 is equals to value of cos 45. The value of tan 45 is equals to value of cot 45. And the rest, what will be the third pattern? Yes, the remaining two will be same, but how? Let us see. Sec 45. Sec 45, the ratio for sec 45 or sec A, friends, is hypotenuse divided by the adjacent side. So what is hypotenuse here? AC divided by the adjacent side, that is equals to AB. The value of hypotenuse is root 2k, AB is k, k and k is cancelled, that is root 2 upon 1, or simply we can write it as root 2. Root 2 upon 1, there is a denominator 1, so that is not required to write it down because it doesn't make any sense, and hence we get sec 45 as root 2. The last ratio, that is cosec 45. The ratio for cosec A, friends, is hypotenuse divided by the opposite side. And again, if I am writing A equals to 45, so cosec 45, that is equals to AC upon BC, which is equals to root 2k upon k, k and k are cancelled, which is again root 2 upon 1, that is equals to root 2. So as I said that we will get the similar patterns here, and I got one, right? I got one similar pattern, that the remaining two values are also equal. The remaining two values makes sense for sec 45 and cosec 45 are also equal. So for angle 45, sin 45 is equals to cos 45, tan 45 is equals to cot 45, and sec 45 is equals to cosec 45. These two values, that means sin 45 and cos 45, tan and cot, sec and cosec, will be similar in every manner, but only and only for angle 45. For angle 45. Why? Because the reason behind this is this one. The sides making right angle, are equal. The sides making right angle are equal, and hence we say that the ratios for angle 45 will be equal for these doublets or pairs: sin 45 cos 45, tan 45 cot 45, and sec 45 cosec 45. This will be equal. Is it clear? So finally, after all of this hectic thing, the derivation, we come to a conclusion that for angle 45, I am going to erase this part here. You can pause the video, friends, and then you can simply write this down because this is not written in the book. After all of this derivation, I can come to a conclusion that the trigonometric ratios the trigonometric ratios for the specific angle 45 are sin 45, that is 1 by root 2, cos 45, that is 1 by root 2, tan 45, that is 1, cot 45, that is also 1, sec 45, that is only root 2, and cosec 45, that is also root 2. So we got the 6 pairs, sorry, my mistake friends, not pairs, these 6 values for only and only angle 45. And I was talking about there are total 5 angles that we are going to study about in this topic. So 6 values each of for this all 5 angles, and that becomes 6 into 5, total 30 values you need to remember. How many? Total 30 values you need to remember. Out of this 30, 6 of them are here on the board right now in front of you, right? Okay, so take a look over this and then we shall move on to the next thing. Okay, good. So I'm going to erase this for angle 45. Now we shall take a look quickly for angle 30 and 60 both together at the same time. You just need to concentrate here now friends, because when we are talking about 30 and 60 both, then we need to think about some type of triangle that we have already studied before. So friends, I have drawn a triangle here. Here, let me name it first of all A, B, C and D. Here, triangle ABC is an equilateral triangle with side 2A. Right? I have taken the side of this equilateral triangle as 2A and AD is the perpendicular. Let me write down the full form. Perpendicular bisector of side BC. AD is the perpendicular bisector of side BC. Perpendicular bisector, that means this will be 90 and this both will be equal. Equal in the sense that D will be the midpoint here, right? What is D? That is midpoint of BC. Right, this D will act as the midpoint of BC. Okay, so here we have taken the side. This is 2A, this is also 2A, this whole B to C is taken as 2A, and as we know that D is the midpoint, so this part, this will be A and this will also be A, right? So you can clearly see that these are all the sides. Now what is triangle ABC? Equilateral triangle, and we know that equilateral triangle has all the three sides same, and also all the angles are 60 degree. So this both angles are 60. In fact, here this total angle is 60 degree. But what is this? AD. And what is AD? Perpendicular bisector of BC. So it will bisect the angle also, and hence this angle here is 30. Which angle? So angle BAD, that is 30. Total angle BAC is 60. So if I draw this figure here, then that gives me, okay, let me draw it here. That gives me a right angle triangle. Sorry. Sorry friends, let me draw it perfectly so that you can come to know that what actually happens. So this is 90 as we see here. This is my angle 90. This is my angle 60, this one, and this 30. This is my angle 30. This is my A, this is my B, and this is my D, friends, as you see. So this will be 2A, this is only A, B to D, that is only A, and we are not having this side AD. Okay, so that is actually now for angle 60-30. Friends, I forgot to write down here that what we were talking about. Here we were talking about the angles 30 and 60, for the specific angles 30, 60. So we got this triangle here, right? Now let us derive this. We will take this triangle out of here. Okay, so in triangle ADB, angle D is equals to 90, as we all know. Angle B is equals to 60, and angle BAD is equals to 30 degree. BAD, so this internal angle, not the whole angle, that is internal angle. And also AB equals to 2A and BD equals to A. Right, so we can apply the Pythagoras theorem now. Therefore AD square plus BD square is equals to AB square. In this triangle, in triangle ADB, we can apply the Pythagoras theorem, right? Therefore we are not having AD, so AD square plus A square is equals to 2A square. Therefore AD square plus A square is equals to 4A square. Therefore AD square is equals to 3A square. This implies AD is equals to root 3A. Okay, AD is equals to root 3A. So we got our third side, that is AD, which is equals to root 3A. Is this thing clear or not, friends? Right? we simply applied the Pythagoras theorem. There is nothing more that we have did here. To find out the value of this perpendicular side AD. Only to find out the side AD, we have applied the Pythagoras theorem. So we got here AD, which is equals to root 3A. Okay, now we require to find out the ratios. So we will take out for angle 30 and then we shall write down for angle 60. So for angle 30 we are having this side, right? So let me write down the ratios first. Sin 30, cos 30, tan 30, cot 30, sec 30, and finally cosec 30. Sin 30, cos 30, tan 30, cot 30, sec 30 and cosec 30. So here we are having the angle 30. So for angle 30, what is the side opposite to 30? BD. What is the hypotenuse? This will be considered as the hypotenuse. So side opposite to 30, that is BD divided by the hypotenuse, which is AB. Right? Let me first of all write down to one by one each and every step. So sin 30 we got the ratio for sin 30, that is side opposite to 30 divided by hypotenuse. Side opposite to 30, this is exact opposite side to 30, which is BD divided by hypotenuse, that is AB. Similarly, we can write it down for cos 30 also. So cos 30, that is side adjacent divided by hypotenuse, which is equals to AD upon AB. Adjacent side, that is AD divided by AB. Tan 30, friends, side opposite divided by side adjacent. So side opposite is BD divided by side adjacent is AD, which is equals to BD upon AD. Right? Cot 30, friends. Cot, the ratio for cot, side adjacent divided by side opposite to 30. So that is equals to AD upon BD. Or if you don't remember it like this, then what did I say? What to do? Just inverse these ratios and then write it down here. So you can see BD upon AD, AD upon BD for cot. Then cos, AD upon AB. Here you can write for sec, that is AB upon AD. And for cosec, you can write down the inverse of sine, AB upon BD. We got the ratios for each and everything. Now what? So you just need to put down the values that we have already found out over there. Put it down the values here. BD, what is BD? A upon AB, 2A. Here, AD, that is root 3A upon 2A. Right? Let me write down the 2 like this. 2A, or you will read it like Roy. BD, that is equals to A upon root 3A. Here that will be root 3A upon A. Here that will be 2A upon root 3A, and here it will be 2A upon A. So we got all of the values here. Put it down here. A and A cancelled, so that becomes 1 upon 2 for sin 30. Here also A and A cancel, so that becomes root 3 by 2 for cos 30. Here also A and A cancel, that becomes 1 upon root 3 for tan 30. Again A and A cancel, that becomes root 3 by 1, which is equals to root 3 for cot 30. A and A again cancel, that becomes 2 by root 3 for sec 30. And finally A and A cancel, that is 2 by 1, which is equals to 2 for cosec 30. Right? So these are the ratios for the trigonometric angle 30. Sin 30, you need to remember directly these values that I have encircled. Sin 30 is equals to 1 upon 2, cos 30 is equals to root 3 by 2, tan 30 is equals to 1 upon root 3, cot 30 is equals to only root 3, sec 30 is equals to 2 upon root 3, and cosec 30 is equals to 2. So friends, these are the ratios that you need to remember for angle 30. In the previous thing that we have remembered was angle 45. That is sin 45 is 1 upon root 2. Cos 45 is equals to 1 upon root 2. Tan 45 is equals to 1. Cot 45 is equals to 1. Sec 45 is equals to root 2. And cosec 45 is equals to root 2. So 6 values before, 6 values now. We have covered 12 values here for the trigonometric ratios. Is this thing clear? Right. So let us quickly continue for angle 60 also, so that in today's lecture we can cover up total 18 values which you will be recognizing, remembering, learning by heart, whatever you need to do. Write it down 10 times in a book, 15 times, 20 times, whatever. You just need to learn these values by heart. So whenever, if I ask you in the class that speak up the values, you must remember each and every values at the tip of your tongue. Okay, so let us see for angle 60 now. Again, what we did for 30, we will do the same process for 60 here. First of all, we shall write down the ratios, that is sin 60, cos 60, tan 60, cot 60, sec 60 and cosec 60. So sin 60, friends, again now we shall look for the reference angle 60. Okay, so sin 60, what is the ratio for sine? Side opposite to angle 60 divided by hypotenuse. Now friends, our opposite side and adjacent side will be reversed. The side that we had opposite for 30 will be now adjacent for 60, and the side that we had adjacent for 30 will be now opposite to 60. So here sin 60, that is equals to AD upon AB. The only magic that continues here is that the hypotenuse remains the same. It will not change. The hypotenuse remains the same. So that is the first one, sin 60 AD upon AB. Side opposite to 60 upon the hypotenuse. Second one, cos 60, that is side adjacent BD upon hypotenuse AB. Right. Tan 60, side opposite, that is AD upon side adjacent, which is equals to BD. So I have written 3 ratios here, and the rest of the 3 ratios will be reversed of this. So cot 60, that is BD upon AD, sec 60, which is equals to AB upon BD, and cosec 60 finally, that is AB upon AD. If you have noticed the ratios, have you anything got similar? Look here. What is this? AD upon AB. What is this? AD upon AB. So you can clearly see that cos 30 is the first ratio there, that is sin 60. Is this thing clear? Yes or no? So I have got one of the similarity. Find out the rest of that similarities by yourself. Right? You can, okay, you might have played a game like spot the differences. Yes or no? So can you spot the similarities, not the differences? Can you spot the similarities? You might. Right? See, you will be having BD upon AB somewhere in that column. BD upon AB, that is the second one. This is the first one over there. This might be the fourth one, and this will be the third one. So cross multiply, cross pattern. First goes second, second goes first, third goes fourth, fourth goes third, fifth goes sixth, and sixth goes fifth. You can see that the cross pattern continues here, right, for each and every ratio. We will remember it like this. We will try to remember the ratios as simplest and as easiest as possible. Okay, so let us continue. AD upon AB, which is root 3a upon 2a. A and a will be cancelled, which is equals to root 3 by 2. So as I said, cos 30 and sin 60 will have the same values, the same ratio, right? Similarly, here we can say that a upon 2a, a and a is cancelled, which is equals to 1 upon 2. The third one, root 3a upon a and a is cancelled, which is equals to root 3 by 1, or you can write down only root 3. The fourth one, a upon root 3a, a and a cancel, which is equals to 1 upon root 3. The fifth one, sec 60, that is 2a upon a, which is a and a is cancelled, that is 2 by 1, or only 2. And lastly, 2a upon root 3a, a and a is cancelled, and which is equals to 2 by root 3. So we got 6 different ratios for angle 60. Again, spot the similarities. Sin 30 equals to 1 by 2, cos 60 equals to 1 by 2, cos 30 equals to root 3 by 2, sin 60 equals to root 3 by 2. Similars. Tan 30 equals to 1 by root 3, cot 60 equals to 1 by root 3. Cot 30 equals to root 3, tan 60 is also equals to root 3. Again similar. Sec 30 equals to 2 by root 3, cosec 60 is equals to 2 by root 3. And cosec 30 equals to 2, sec 60 is equals to 2. So we got 12 different ratios here for angle 30 and for angle 60. That is 6 for 30, 6 for 60, and the 6 more that we have derived previously for angle 45. Right? So friends, we will keep it here up to this much. In today's homework, you will again write down all the trigonometric values for specific angles 45, 30 and 60 in a fair book. Make a table and you will try to memorize each and every value, so that whenever you are required to get the values, you can simply remember and you can put down the values in the sums as and when possible. Thank you friends.